Hello and welcome to the latest video in our series about mortality. I'm Andy Wilson from Macroanalytics, and today I'm joined by my colleague Paul Horgod.
Hello.
And in this video we're going to talk about standardised mortality ratios, or SMRs as more commonly known. So in this video we're going to provide an overview of SMRs, and in a later video we'll go into them in more detail. So in the previous video we discussed crude mortality rates and how they're not appropriate for comparing organisations. So there are potential differences such as the services that trusts provide, the demographics of patients in their catchment areas, or the case mix of patients who are admitted. All of these things make using crude mortality rates to compare organisations inappropriate. So how do we get around this? And this is where standardisation comes in. Standardisation is a way of making small adjustments for different things. So in the NHS it could be things such as the age of patients who are admitted, the route of their admission, such as if they're emergency or elective patients, the severity of the condition that they're admitted with, the deprivation of patients, or whether they're receiving palliative care or not. Okay, so you recall from the previous video that crude mortality is calculated by dividing the number of deaths by the total number of discharges. Similarly, the numerator for a standardised rate is calculated using the same numerator, more commonly called the observed death. But this time we introduce the idea of expected deaths as a denominator.
Oh, what? We expect people to die?
Well, yeah, in reality we do. We know that when patients get admitted to hospital, unfortunately some of those do die. So this proportion is calculated based on the attributes I've just said earlier, and this is how we come up with the idea of the expected number of deaths.
So how is this expected number calculated?
Well, that's quite complicated, and it's a subject for a later video. But for now, if you accept there's some sort of black box wizardry that goes on. But it is an important point to note that with all these things, there's a bit of uncertainty that goes on.
Oh, I like uncertainty as much as I like volatility.
I know, me too. But it comes with the territory of statistical models. Now, this quote's over 60 years old, but I still think it's perfectly valid.
So now you tell me we've got this all wrong. What am I to believe?
Stick with me. It's not so much that they are wrong as that they have a level of inaccuracy and imprecision. It's important to remember the second part of this quote, that some are useful. Now the real trick is to establish when it is useful, and how do we do that? Now when we calculate crude mortality rates, we're calculating something that is accurate, but isn't all that useful for comparing organisations. And when we calculate standardised rates, we're producing something that is useful for comparing organisations, but does have a level of imprecision.
Oh, so how was that sorted out then?
Well, NHS Digital have a more sophisticated way than using confidence intervals to calculate mortality outliers, and we do cover that in a later video in a bit more detail. But for now we're just going to look at 95% confidence intervals, which is an important process in understanding levels of precision. This chart shows the shimming, which is the summary hospital level mortality indicator values for the trusts in the northwest of England, together with the range of the 95% confidence intervals. It's the 95% confidence intervals that are important to note here. Only when there is no overlap between the lower limit of one trust and the upper limit of another trust could you say that there is a statistically significant difference. So, for example, the lower limit for Blackpool is lower than the upper limit for the next 6 trusts. And similarly, the upper limit for Salford is higher than the next 5 trusts. In both of these situations, there is no statistical difference at the 95% confidence level in the chosen trust than many of their neighbours.
Oh, I see.
So this concept of 95% confidence intervals is very important when we split the data. So if we're looking at different age groups or different disease groups. And it's only when the two confidence intervals don't overlap that we can say there's a statistically significant difference.
Mm-hmm.
This is equally valid for if we're looking at different time periods. In a later video, we'll look at the different methodologies used in the NHS. Goodbye for now.